Okay, Mars number 2. We're still talking about Olympus Mons. The reason it got so big is this same hot spot that's creating the volcano is up here on the Tharsis Bulge. Here's Olympus Mons right here. And then there's like 3 volcanoes in a row over here. Because that hot spot has just been pushing continuously magma and stuff up for millions and millions of years, hundreds of millions of years, and the plate doesn't move, so it just makes it bigger and bigger and bigger. So even though Mars is half the size of the Earth, it has a bigger volcano than the Earth does. Also we see on the Tharsis Bulge, and you can see these are the volcanoes over here. See these volcanoes, this row of volcanoes over here? We see this giant valley, but we really don't call it a valley. It's more of a canyon, but it's not really a canyon. Because we think of canyons like on the Earth, like the Grand Canyon. It was created by the Colorado River. Colorado River just eroded away over many millions of years. As the ground kept lifting up, the Colorado just kept cutting through it. But here, this was actually a split. So it's a crack more. So what you did is as they pushed the Tharsis Bulge up, all that material pushed up and cracked the surface. And this crack here, it is several thousand miles long. It would stretch all the way from Los Angeles to New York. So again, it has the biggest canyon in the solar system too. We call this Valles Marineris. And on the Earth, the Grand Canyon in Arizona would fit nicely in one of these little side channels. It would be just a tiny part of this. This is huge. All right, and then we have this region of cracks or fractures up here. This is called Noctis labyrinthius. Okay. These are just geological features because of this. This whole region here is the Tharsis Bulge where it got pushed out, and then the material just cracked, or the surface just cracked on top of that. So it has very giant geological features, even though it's not as big a planet. All right. So what's the surface look like? Guess what? This is a picture from the surface. We have had, over the last 20 years, numerous landers, rovers, and probes that have gone to the surface. In fact, the first ones, the Viking landers, landed way back in the 1970s. They were the first one to actually land there. That was when the US decided to go to Mars. We landed the Viking landers on Mars. And that's when the Russians went to Venus, and then we got the pictures from Venus. But if you land anywhere on Mars, or I'd say 90% of Mars is going to look exactly like this where you land. As long as you don't land on the polar caps, it all looks the same. You have lots of rocks sticking up. These are igneous rocks, which are volcanic rocks, most of them. All right, and then you got this dust. The dust is this reddish color because it's iron oxide, rust, essentially. The iron has combined with any oxygen and made the soil kind of this rusty. Because of that, and when you have the winds, it blows it around, but the sky also has this pinkish reddish color. It doesn't have a blue color because you have so much dust that's always in the atmosphere, even though the atmosphere is very thin. And the atmosphere is so thin that even in the daytime, if you're looking straight up, so you're not looking through the atmosphere, you can see stars because the atmosphere doesn't block it out, because the atmosphere is so thin. All right, here's more pictures from rovers. This is from Spirit and Opportunity, which were 2 different rovers that landed there. These rovers did great. They landed there and they said, okay, we're going to land these rovers on Mars. We hope they last about 90 days because it's tough conditions. It's very, very cold. It's nasty. You're further away from the sun. You don't get as much solar energy, and they're run on solar power. And they lasted not only for 90 days, they lasted for some 900 days. Spirit did an Opportunity, finally died like 1,000 days later, meaning they lasted a whole Martian year and more, which nobody thought they'd survive a Martian winter, because you talk about harsh winters, you're talking like Antarctic level winters, but they did. Now they had problems that time. There was one time when I think it was Spirit completely died, the power ran out because all the dust had covered up the solar panels and sunlight couldn't get through. Good thing is a windstorm came up and blew the dust off, and the sun then hit the chargers, and they recharged the batteries and fired it back up, and it worked. Opportunity, it had the wheel, one of the wheels got stuck, and one time it got stuck in a crater, and it took it like a month to figure out how to get out of this crater that it went to. One of the wheels went bad, and it was dragging its wheel around, but they did great. And we learned a whole lot. One of the most interesting things they wanted to learn was this. You see these rock outcroppings? This is what they want to look for. So the idea was going to Mars is we want to follow the water. So you want to follow the water on Mars. Why? Because we think, in fact we know, in the past, Mars was warmer, had a thick carbon dioxide atmosphere, and liquid water on the surface. Meaning Mars is very different now from what it used to be. That is intriguing, especially from a, hey, let's look for life in a different place in our solar system idea, because you have liquid water, you got a shot. Everything we know, all life we know, has to have liquid water on the Earth. So we're like, well, if there was liquid water, there's a chance there was life. Even if it's just microbial, there's a chance for life. So what they did is they looked for evidence of liquid water. Well, you look for evidence of it. You look for evidence not in the dust, you can't find it, but in the rocks. You see if there's evidence that the rocks were ever below water, because different chemicals form different minerals, and you can see that, you can see layers, and so that's for what the missions have been lately, is to find the water. All right, these are more pictures. This was a picture of how they landed the spacecraft, which is kind of an interesting way to do it. So this is how it worked. They had the spacecraft come down, it had a parachute, and then it had a ball. The spacecraft was inside it. The ball was like a giant airbag surrounding it. And before it even got to the ground, they released the parachute, and this ball hit the ground and bounced, and then rolled. So instead of trying to have a nice soft landing, they just kind of let it go and let it bounce and roll. And then they let the airbags deploy or pull out. It worked perfectly. It flipped on itself and it drove off. They did this for like 3 or 4 missions. It worked great. But then they said, hey, let's look and see where the original impact was. This is it right here. So this is when they dropped it. Well, these are heat shields and parachutes and stuff that were dropped. So we're littering on Mars, essentially, leaving debris around, but this was created by Earth people exploring Mars. All right, this is just another panorama. And like I said, Mars looks pretty much the same wherever you look. Slightly different color. That's just the way they colorize the picture. It's not really probably that different in colors. These are probably pretty accurate because these are new cameras, very good cameras that they have on their rovers now. This is a self-portrait of the I think it's Spirit. You see all the solar panels. That's what charges it all up, and then it has the cameras sticking up here. They have cameras off the front, and they can manually drive it. It's like driving a remote control vehicle. They drive it from Earth. The challenge is you can't drive it live because your signal can be like 20 minutes before it gets there, depending on where Mars and Earth are in their orbit. So you can't say turn right because it would take 20 minutes to turn right. So what they do is they give it a series of commands of what they want it to do. They send it to it, and then it runs out a path. It also has sensors, laser sensors, and sonar sensors. I don't think sonar sensors, I think, what do you call it, where they send out a beam and comes back. The idea is that if they run into rocks or something like a cliff, it'll just stop and wait until it gets better command. It's made to protect itself in case you tell it to do something wrong. All right. One of the things it did, this is a false color photo, but it found the rock wall, and it went up here and it drilled holes in it. You want to drill holes because you want to see what's inside. So it actually had a drill, went up to the wall and drilled a hole in it. And notice these little round circular things. These they call them nodules. Those are minerals, but those minerals are only created if this was underwater. Meaning, just seeing these nodules here shows that at one time this rock was underwater. It was under a lake. So we know that there was water there. We know that there was liquid water on Mars. All right, let's talk about the polar caps. The polar caps have 2 parts. They have their permanent cap and their seasonal cap. The permanent part of the cap is made of water ice. Frozen water, and that's what you see over here. So this would be summertime. And that's water ice, but it's way thicker than this looks like. It looks like, oh, there's only a little ice. Actually, that ice extends all the way out to here. But all the dust that blows along covers up the ice. But they landed a probe, what they call a Polar Explorer, up here at a very high latitude. It dug under the soil 3 inches and it ran into ice. So there's ice all over this. It just gets mixed in with all the dust. So it's very dirty ice, but it's frozen under there. But then when it gets cold, when it's winter time, it gets so cold that the atmosphere actually freezes to the ground. When we get this seasonal cap, this is carbon dioxide ice, or on Earth we call this dry ice. Meaning the air temperature gets cold enough, the atmosphere freezes onto the ground. And then in the summertime when it warms up, that carbon dioxide then evaporates and goes right to being a gas, what's called sublimating. So this is what it is with the seasonal. You see this big bright white spot, that's carbon dioxide ice. And then in the summertime all that melts and all you're left with is the polar cap. And the polar cap never the permanent one never gets warm enough to melt that ice. It just doesn't happen. It's in what we call a permafrost state. Here's another picture of the polar cap. You can see this is ice, and you can see how the wind is blowing the dust in here as it circles around in here. And we know the ice actually extends way out here. It's just under the dust, so you can't see it as well. This is the southern polar cap, by the way, if you're curious.